Okay, so thanks all for coming to listen to me call myself an idiot for the next 45 minutes. So basically, I did this talk basically because I got dared to by the DDD Melbourne Twitter account. I submitted this kind of as a joke, and then it got voted in, and then it got voted in here. So apparently everybody hates me and wants me to make a fool of myself in public. So my very first lesson is don't submit talks to conferences on a dare. Now I have to call myself an idiot in public. So thanks for coming to see that. Before I get started, thanks to all the sponsors. These events can't happen without them because they're not cheap to put on, and without sponsors to put up the money, you'd all be paying a lot more or be doing something terrible on the weekend, like listening to your family. Nobody wants that. So a bit about me. I'm an escapee from the barbaric wastelands of Western Australia. So I recently moved to Melbourne. It's a much nicer city. It doesn't die at 6 p.m. I strongly recommend you all move there. I was asked by my tech lead if I was going to remove this point from the Melbourne version. Clearly I'm not. Been a professional developer since the late 90s, which makes me officially old, and it also means I've seen some shit. Let's not talk about that. Okay, so I've mostly worked online business systems, so take everything that I say in the context of what my experience is, and these days I mostly work on back-end stuff. So the last time I did any serious amount of HTML, it was still okay to lay everything out using tables. I miss those days. Those days worked. I am not doing CSS. I'm just not. And I've been on projects that went very well. I've been on projects that failed badly. Fortunately, I've never done anything nearly as bad as this year's census. So, why am I doing this talk? So I had a friend suggest that I was running myself down by submitting this topic, but I don't actually agree. I think as an industry we focus way too much on the new shiny, and negative comments are reserved for people who are doing other stuff that we don't personally like because it's not our style. And I think that ignores some fundamental truths. I think that everybody makes mistakes, and failure is one of the best ways to learn things. So I want to encourage people to be appropriately self-critical. And I'm kind of leading by example. So this talk is actually all about me. Meet my ego, please. So everything in this talk is a mistake I made. Because criticizing other people is easy. It's also a lot of fun. But most of the people I could criticize aren't here. There are actually a few of them. Hi, guys. Reese, for instance, get me at the pub later. But, criticising in public could get me attacked by lawyers. Also, more seriously, if you can't admit the areas where you need to improve, you're not going to be able to do so. So every talk at a conference needs buzzwords. These are my buzzwords. I've now met my buzzword quota. You're not going to be seeing these buzzwords again. So, onto the rant. So, back when I first started, before MVC, before web forms, before .NET itself, Microsoft's web development platform was called Classic ASP. Now, we didn't call it Classic ASP at the time. Much like World War I wasn't called World War I at the time, and for much the same reason. So pretty much everything bad you've ever heard about Classic ASP is true, even the lies, especially the lies. And at the time, I was a very junior developer with excessive confidence and inadequate supervision. And as bad as Classic ASP was, and it really was, never underestimate the ability of a junior developer to make things worse. And I did. So I was looking for a way to build systems better. And I found what I thought was the answer in a Microsoft example project. It involved building, yes, laugh from the audience. Somebody else has made this mistake. Involved building business systems using a business layer and a data layer component in everybody's favourite language, VB6. So the basic premise would you have a classic ASP code, we call a VB6 component, business layer component, And that would do all of its data access through a VB6 data access component. And it came from Microsoft, so it must be a good architecture. So I then proceeded to apply this to everything. So it looked kind of like this. So you had your classic ASP website running a really old version of IIS. Then you had the VB6 business layer and the data access layer, and then finally you got to the database. Now clearly this is better than just having classic ASP because it's got layers. And now everybody loves layers. Now I don't want to sound like I'm against separation of concerns because that's very important. But putting business logic into VB6 like this is hard. VB6 doesn't make it easy to pass around complex data structures, and it makes the dev cycle a lot longer. So in practice, the business layer, in almost all cases, created an instance of the data access component, and then forwarded whatever call it got straight onto the database. That added no value whatsoever. The data access component does a query against the database and returns a record set that gets all the way back up here. And it's useful to have a separation of the query from your other business logic, but putting in the VB6 component here, no value whatsoever. It just adds overhead for no actual benefit. So, second lesson. Write code because it's actually adding value to your project. If your architecture is demanding that you're writing a significant amount of code that adds no value, then your architecture is defective. The value of an architecture is not determined by where it comes from or who promotes it. An appeal to authority is both a logical fallacy and an extremely common reason for doing architecture. We've all seen, Fowler says this, or Greg Young says that, and quite often they do. But expertise is a reason to consider someone's arguments, but you still need to actually consider those arguments. And it's really common to actually ignore the caveats that experts will put on their architectures. They might say it's not applicable in X, and you go off and apply it to X anyway because you heard the headline, X is great for Y, and it all falls in a heap, and then you say, but I followed the experts, and then you get fired anyway. So it's really common to implement a misunderstanding of an architecture rather than actually implementing that architecture properly, because going and looking at, or actually reading into that detail takes a while and it's tedious and boring, and we've got better things to do to find out what the next shiny thing is. Also, junior developers do stupid things if you don't watch them closely. Now, we've all done this. It's a normal part of the learning process. And as a senior developer, it's your job to correct junior developers without, making them feel stupid or crushing their enthusiasm. Because you were there once, everybody goes through this. So, second example. This was about mid-last decade, working on a line of business system for a government department. And this would implement the entire process required to support a piece of legislation. It was based on a workflow engine because we're partnering with another company and we just didn't know any better. And it was built to a pretty tight 6-month deadline that was defined by the legislation. And it went live on time, and the client was actually quite happy with it. The system even won some fairly minor awards. So it'd be quite easy to chalk this system up as a win and move on because, happy client, award, yay, everything. Great project. But that overlooks, there are a number of potential areas for improvement in building this project that in other circumstances, if we'd not been quite so lucky, could have completely derailed it. So we implemented this with a web front-end server to provide a UI, and we had an application server that hosted the web services and that we used to perform all the business actions and do all the data access, and that also hosted our workflow engine. And we had some other components that aren't directly relevant here to connect to other systems. So, why did we have separate web and application servers? Well, it was the style at the time. And in this usage, there's no real benefit to it. There were minimal security benefits to separating this stuff out. And there was no real difference in how we needed to scale any of the components we were putting on either of them. But it meant we had a lot of layers. We had all of them. We had client-side UI and web server UI logic and web server business logic, and then we had a client to connect to the back-end, and then we had back-end web services and business logic and this data access layer, and it's extremely anemic domain model. And then eventually we had a database, occasionally. That's another thing I can't blame on myself. So this resulted in the system having many layers, and every single operation that we did had to go through all of these layers. So every single query and every single business logic operation had to have one of these things instantiated and had an additional web service call. And so most of these layers didn't actually do very much, but had overhead. So we basically separated the web application server and the business application server, introducing an unnecessary network call, and that introduces additional latency, but it also introduces an additional risk of failure. We also had some wonderful issues with the design of our API. So we had a standard set of DTOs that we used by the web API. That meant that the same representation of the entities was used in every single case. It's not exactly sending the entities themselves across the wire, but it's really inflexible because most users don't actually need all of the data on those entities, or they need it in an alternate format. It's quite inefficient because you're sending a lot more stuff around than you actually need to be. It's a big source of bugs. If the client and the server have different understandings of which part of the data is actually populated in this particular call, because we didn't bother sending that field because they don't need it, but they do need it now. Now we've got another reference exception. That's not a great way to run a railroad. And it heavily incentivizes the business server to basically just be a CRUD service. And CRUD services are an anti-pattern. They're extremely chatty. We already have also a more secure, a more performant, a more stable, and more flexible CRUD service. And we call it a database. And some very, very smart people work on making that a very great platform, and we're basically slapping a layer of not very good code on top of it. So that wasn't brilliant. And then we come to this. Yes. So at the time we did the project, I didn't know of Hibernate, and I'm not actually entirely sure it actually existed at the time. But anyway, yeah, I wrote an ORM, because everybody should do that. So yeah, I had read Patterns of Enterprise Application Architecture, great book. I was also quite bored. So long story short, I wrote my own ORM, and I included it in the client project. It was pretty primitive. It required a lot of custom code for each mapped entity. You needed to manually flag things as dirty. You needed to still write a fair bit of SQL yourself. And it didn't really support custom queries particularly well. It was an interesting exercise, but it should never have gone into production. So fun fact, I had a bug in it in how it implemented many-to-many collections. Not a great way to represent entities, but we had a lot of them in this particular design. And this bug was never hit in how the application actually used this ORM. But after I moved on, the support team wrote a migration tool that used it, and they hit the bug, and it wiped out all the associations between a whole bunch of entities. It basically deleted them all and then went put them back, and something wasn't flagged as dirty, and it didn't put them back. So that was fun. That was a really fun support call to get from the team. Fortunately, they hadn't actually done it live on production. We had various other backups and such anyway. But yeah, that was an interesting call. So yeah, other problems. So we built this system around a workflow engine. And in order to participate in transactions with that workflow engine, all your code needed to be registered in a wonderful Microsoft technology called Code+. That introduced a registration step after building the application server solution. And if you forgot to do that step, then sometimes everything would work, and sometimes it wouldn't. So that had a lot of friction to the development process. We'd already had two solutions and a whole lot of low-value layers, so more friction wasn't exactly popular. And on at least one occasion, I reacted to complaints from a co-worker by getting angry and telling them essentially to harden up. And I really owe Pete an apology for that, because I should not have done that. There were ways that friction could have been reduced, but I didn't implement any of them. because, I was actively ignoring feedback from my co-workers on that. The architecture had a defect. They were telling me that. I was not reacting to that feedback. And that was partly because I didn't actually work on that stuff regularly. I was building a lot of infrastructure stuff, so it didn't register to me as a significant issue. Now, the time it would have taken me to fix that would have paid for itself many times over in reduced overhead for the rest of the team. So, lesson 5, don't distribute without reason. Adding communications overhead and additional failure points has to be something you can justify with concrete evidence. If in general you're going to see more reasons to distribute logic horizontally, break out different areas of functionality rather than separating out your different vertical layers. This is not to say you should build an entirely synchronous monolith, but it's basically an argument to be intelligent about where you put your boundaries. Where that will be depends on your particular application. Just think about them, don't just put in an application server because everybody has them these days. Tailor your models to their use case. Reuse of DTOs is massively, massively overrated. Defining a DTO is easy and cheap, and with no logic on them, they have very, very low maintenance overhead. Mapping directly into the format you actually use and need is significantly much more efficient, more expressive, and less error-prone. It doesn't cause confusion as to what parts of the model is actually populated, or what things an operation needs. Structural similarity is no reason to share models. It couples functionality that you may wish to separate or vary independently in future. Sharing should be restricted to basically only the very low-level data types, and it generally needs to be something that is actually consistent everywhere. Maybe in address format, but there aren't very many other examples in most systems. There are relatively few models that are actually going to be treated like that as an atomic unit. Don't write frameworks unless you really, really need to. Writing a framework, writing an ORM rather, fun exercise. I learned some stuff, but being honest, it wasn't anything near what would qualify as a real production quality ORM. It was basically a convoluted data access layer with delusions of grandeur. Writing frameworks doesn't add business value. It may enable you to deliver better deliver business value with other code, but you need to be able to actually justify that doing that. Think very long and hard before you build an alternative to things that already exist, and also consider whether you actually need them in the first place. A standard, run-of-the-mill data access layer with no ORM component would probably have served this project a lot better. And also react to feedback. Feedback is necessary to correct errors, and everything has errors. If you don't acknowledge your errors, you can't fix them, and they accumulate over time. And not fixing your architectural issues has significant costs in terms of wasted effort and increased defects. So when people give you feedback, react to it. And also, development teams succeed or fail collectively. No one cares how good your code is if the system doesn't work. It's really easy to get siloed. I'm doing this thing and everyone else can go to hell. That doesn't help. Getting all your things done at the expense of your team members is unprofessional, and working well in a team is a key developer skill. So are you really a 10x developer, or are you just pushing all your work onto future maintenance developers? So, second, example 2.5. On the basis of the previous system, which was reasonably successful, we were involved in a couple of other similar projects. These were not as successful. Many of the factors in that don't involve me personally, so I'm not going to go over them. But there were a few things. So one of the projects had an audit requirement that we know who's performing actions in the system. And one way that you can audit everything that somebody does is to propagate their identity between servers using Kerberos, and log everything. So I say that in the strict sense that it can be done. I'm in no way recommending this. It's almost certainly a bad idea to propagate your user identity all the way down to your database. But let's say you're like me and you accidentally said you would do it in the tender response, and now you're kind of stuck with it. So we did that, and you could tell who did anything against the database, and that was nice, and we had some audit tables populated by triggers. Don't do that either. Anyway, it worked fine on everyone's development machine. Yay. And then we went to an environment that looked more like production, which we didn't get immediately, and that had multiple servers, and it did not work at all, to the extent that every single service call failed. With security issues. So apparently Kerberos works very differently between services that are all running on the same machine versus services that are running on different machines. We've put a lot of effort into getting that to work. Unfortunately, we discovered that very late. It took a long time to get things working, and we should have changed approach. But we committed to it, and we thought that changing our approach was difficult politically, which was not a good reason to make an architectural decision. So, asynchronous messaging is excellent for decoupling components. It removes your typical coupling, it allows retry, it allows message reordering. PubSub allows models where, an event-driven model where consumers don't have to be known to the producer. It's also a terrible default for consuming all commands in a system. To get a result of something that you submit asynchronously into a client, you can poll, you can notify the user asynchronously, such as by email, or you can lie to them and tell them that something's been done and then just hope it actually does succeed in the background. And none of those options are particularly good. Polling is expensive to implement and to run. Async notifications are not always appropriate, particularly in business processes. You don't really want to be halfway through filling out a form. You click next and it tells you, we'll send you an email when you can fill out the next page of this form. That's not going to work. And lying runs the risk of destroying user trust in the system, because the system is lying to them. Fairly obvious. So, XML. Everyone loved XML last decade, and everyone loves JSON this decade. And what format will we love next decade? I don't know, emoji. So, all systems of any scale need some level of configuration. And that tends to end up in configuration files, which in this project were XML. And our configuration went slightly overboard. We used all of the XML. You can't have any XML. We've used all of it on this project. There's no more left. So, in addition to your standard web config, where Microsoft themselves went overboard with XML, so we had that for multiple websites. We had XML configuration for all of our dependency injection. Every single thing that got injected was configured by XML. So we had literally thousands of lines of XML. In case you've never done this, specifying generic types in XML is not fun and really, really, really easy to get wrong. And really, really, really hard to debug when you do. And it needed to be modified every single time anybody added a service class, which meant a lot of people were modifying a thing that's really easy to get wrong and really hard to debug. So that's problematic, plus it's a source of merge conflicts, which is another source of bugs. So it pretty much guaranteed that people would change something incorrectly. But wait, there's more. Yay. So we also defined all of our very, very fine-grained permissions in XML. So we had multiple roles, and which services a role could call were determined by large XML files. And when I say services, I mean every single method had its own configuration. Good luck testing that properly. That really obscures who can call services. Fine-grained permissions on a per method basis, huge overhead, and it's really difficult to change in bulk if what roles can do changes, or if you add a new role, or if you remove a role, or you merge them, or split them. Yeah, it's not fun at all. So, testing your architecture should be done in something that actually looks like your production environment. Your laptop, in most cases, doesn't look like your production environment. You should do this early, And you should do it before you actually commit to that architecture. Because once you commit to something, it gets really expensive to change, particularly if there are contractual restrictions on what you can do. You need to make your test realistic so you don't miss things. So testing on a single machine missed the completely different security behavior that occurred with multiple machines. And finding out things aren't going to work at the end of the project with your deadline rapidly approaching is highly unpleasant. I don't recommend that experience. If you're fighting the system, consider a different approach rather than continuing to bang on the solution. If your approach isn't working, you've essentially got two options. You can keep expending effort in the hope you'll somehow get things to work, even though you haven't yet, or you can admit it's not going to happen and see if you can accomplish the goal some other way. Now, our security propagation problem had a solution, but it took a lot of my time, took the time of a contractor, and also one of our infrastructure people to find that. And that effort could have been much better spent elsewhere. There are also other ways we could have accomplished the actual objective of the client in a much more effective fashion. So we got stuck on a particular solution, but instead we should have been focusing on satisfying the actual business requirement. Use asynchronous messaging judiciously. Use it to improve the robustness and decrease coupling horizontally. We use it vertically, ensure it's a good fit, and that there are benefits to justify that additional cost. Asynchronous communication vertically involves complex questions of how to deal with failures and client expectations and result notification. Horizontally between components, we have known patterns such as dead letter queues, but we don't really have those with vertical communication so much. If a customer, say, submits an order, they have an immediate expectation of, say, receiving an order number, but they'll have a much more relaxed expectation of when they'll receive an order confirmation email, particularly as email is not actually instant itself. So in general, consider submitting commands from users synchronously and producing events other components can produce asynchronously, consume rather. But it's still worth ensuring the requests are idempotent so you can handle failure conditions and retry. Automate your configuration. If you can write code to work something out, do that. Type scanning would have reduced our thousands of lines of XML to a couple of lines of C#, with a couple of additional lines for some of the exceptions that can't be registered by convention. And that would have been massively, massively simpler to maintain. And in most cases, you could have just added service classes without having to do any configuration whatsoever, which would have been a huge gain in development efficiency. Making configuration decisions as soon as possible. Basically, in order of preference, you should hard-code things that will never change. Expressing codes, things you can determine automatically, for instance, type scanning assembly to do all your DI configuration. Then you put things into configuration files at deployment, and then last and most reluctantly, you put things into a data store, things you have to configure at runtime. Every configuration point is a potential difference between your development and production environments, and therefore a potential source of bugs. So the final example is a line of business system to support core business functions. And this is basically a pretentious way of saying it's a system to do important stuff that a business relied upon. And it was built service-oriented, and we had a lot of them, so many services. And it was built with one of the best groups of people I've worked with. This system is in use currently, and it's delivering significant business value. But that doesn't mean that everything I did on it was ideal and perfect. So, this system had on the order of 100 services. That's quite a lot of services. And every single one of these services is fundamentally the same architecture and infrastructure implementation. And one is not a lot of architectural styles for 100 services. I wrote most of the infrastructure. There are a lot of nice features for retry and error handling and automatic registration of handlers and all kinds of wonderful fun stuff. But a single approach does not suit all elements of the system. Some things just need simple CRUD. Some things need really sophisticated domain modeling, and some things kind of end up in the middle. So no one architecture is going to capture the requirements of every single element. So as part of building the infrastructure, I built the simplest domain that we had so I could validate the infrastructure worked. And that got implemented as an anemic domain model with transaction scripts. And that was because it was easy to do that, and as the simplest domain, we had virtually no business logic in it. And then I called it good, and I went on to do other things. And then the team went on to do much more complex domains using the simple domain that I built as their template. And it turns out that transaction scripts don't scale well to complex domains. They tend to produce very duplicative logic. They produce poor models that don't express business concepts clearly. They distribute business rules around in vast walls of procedural code. So whereas they're fine for doing things with basically no business rules, they tend to be actively harmful to things with complex domains. And by the time this became apparent, I had locked in some design features that made switching to a richer domain model problematic. Not impossible, but more effort, a lot more effort than it should have been. So the architecture we had incentivized small services really quite heavily. Generally, we had a single aggregate per service. And this was based on how we decided to implement some of the fundamental design patterns of the system. And that's not without its costs. It's a lot more moving pieces to deploy. It's a lot more configuration. It's a lot more inter-service communication. So, we really should have proved some more realistic concepts in our proof of concept. Building the infrastructure against the simplest domain hid that we had more complex domains that would have significant issues with some of our implementation decisions. A more complex proof of concept would have illustrated that our services were too fine-grained. Essentially, we built one simple service in isolation as a proof of concept for a system which had multiple complex services interacting. And that did not prove the concepts that we actually needed to. So, each component should have been built with an architecture that actually matched its requirements, environment, and importance. Over-engineering has implementation costs, to be more expensive to deploy and run and maintain, but under-engineering can also result in higher defects and therefore excessive maintenance. So either way, you're spending more effort maintaining it than you really should. Low-quality models don't really express the domain efficiently. They generally produce a lot of duplicative procedural code that a cleaner model will eliminate. Ideally, you could do simple things as simple services, and more complex things as complex services. So that implies what you need is a constrained set of architectures to choose from, rather than a single architecture that is not fully suitable for many of your cases. So my issue with the term microservices, apart from the abuse by marketers everywhere, is that it specifies the size of a service in the name. Services should be large enough to do something well, and no larger. But specifying that they should be micro tends to make you focus on how can I cut things out of this service, even if that's not actually appropriate. How large something is and what it should do depends on context. There's no real right answer. There are wrong answers, though, and making every service into literally the smallest possible thing is one of them. Some things naturally clump together, and it makes sense to group those things together as a service. So how are we doing for time? 2 minutes. So a few other random things. So reaching for default frameworks. Fairly common trap. I have a solution. Now, what's your problem? This used to be extremely common with SharePoint. But I shouldn't actually say that because I have never made that particular mistake. With SharePoint, I made it with other things. So it's okay and expected that you'll be familiar with particular tools and frameworks. That's part of your job. But what's not okay is pulling them into your project immediately without considering if they're actually adding any value. Because that tends to lead to overly complex solutions that have more infrastructure than the project actually warrants. And one of the leading contenders in this space for me is use of DI containers. DI containers are great, and in many domains they add an awful lot of value. But using them is not free. It requires developers to understand the DI conventions that are in use. Complex registration can obscure how things actually fit together, and lead to errors due to false assumptions. And so for very simple projects, the cost of using them may be unwarranted. Maybe you should just use IOC and pass in your dependencies manually. So ORMs, in addition to the fact that I wrote my own, they're also very powerful tools, and I have massively overused them. In particular, using ORMs for queries is generally terribly inefficient. I spent a large amount of time trying to write simple queries in what would be a simple query, rather, if I was writing it in SQL, but I'm trying to use the ORM APIs that make them incredibly difficult. Thank you, and hibernate. So that's really not an efficient way to do things. Now, link can make things less terrible, but still not as effective for many complex queries. So quite often, what you should be doing is just throw a SQL query to the database and map straight into code. And there are some quite nice frameworks out there for doing that now that mean you don't have to deal with ADO.NET, but you can still write SQL quite efficiently. So probably the worst feature of ORMs is the missed feature called lazy loading. So naturally, I've used that a lot. It's a really great way of ensuring that you have performance issues in production, because you will use it and it'll be fine on your development data set, and then you go into production and it's pulling in half the database, and your database is a terabyte, and suddenly your system falls over and you're unpopular and fired. It's also a really great way of causing data access issues in your presentation layer, because something's being lazily loaded way up in rendering the page when it should have been queried already. So when you query a database, you should basically retrieve everything you need in one operation, and that should return a simple model that conforms to the data format your usage actually needs. You pass that up, and it's done, and you do no further database operations. So we often structure code because we need to be able to test it. Now, if the only reason your code is structured the way it is to enable testing, then it's unlikely to be structured as well as it can be. That tends to produce code with a large number of mocks. Mocking frameworks are great for what they do. There are certain cases you can't really test without them, but you should not be by default trying to mock out the rest of your system just to test anything in isolation. That's probably a warning sign that your structure is not as efficient as it could be. So warning signs, and I've done all of this stuff, is inheritance hierarchies in tests. How much stuff do you need to set up that you need to have a 5-level big inheritance hierarchy to set up all your test fixtures? Large constructors in test classes, that says that you've got a whole lot of state that you have to magically remember how it works every time the test breaks. That's not going to be a fun experience. And having a lot more setup code than code in the unit under test suggests that you've got a very big context for code that isn't actually delivering all that much value. So, code conventions. Everybody loves arguing about, where we should put our braces and where we should put our spaces after the if statement or inside the brackets. Or nobody cares. The compiler doesn't care. And I've called meetings and written documents to define coding conventions. And that was allegedly because keeping code consistent adds a lot of value. No, it doesn't. Telling developers to write roughly in line with language conventions and make your code readable. If you can't read the code because the brace is next to the if statement rather than on a new line, there's something deeply wrong with you. And not just because you're at this talk listening to me around. So, don't build reusable libraries. Building reusable components is hard. Platform vendors will try and cover the fundamentals, and for the cases where they don't, then there are people who will provide you components to do the other stuff, and some of them may or may not be sponsoring this conference. I didn't change that line since Melbourne. So they put a lot of effort into that development, a lot more than you're going to be able to. Reusable component has to be applicable in multiple scenarios, has to be sufficiently easy to use, but it's worth using in those scenarios, has to be maintainable so that your bugs can be fixed and can continue to be used as your project evolves, and it has to actually be maintained so that you're not stuck with an old version forever, because I'm sure we've all encountered code bases which has an old version and hibernate that's from like 2008, and that's an alpha, but you can't change anything because it's used in so many places. It'll be like 3 months and no value to replace it. That's not a fun situation. So it's not a task to be underestimated. So naturally, on a couple of occasions I've attempted it, and it didn't really work out particularly well. The components that result tended to be inflexible, poorly maintained, and generally not worth the effort of using. In hindsight, that's not really a shock. So in most cases, it's actually better to copy code between projects than extract it into a third project that everyone's going to magically maintain. Because that makes ownership and responsibility for that code clear. If it's in your project, you own it, you maintain it. If it's in a third-party project, well, that's tragedy. They're commons, nobody gets it out. It also allows you to more extensively customize the code to your particular usage without having to worry that you're breaking it for everybody else. So I think we're almost at time. So key points. Back to feedback. Most of my failures involve downplaying or ignoring feedback from either the difficulty of working with the system or directly from coworkers. Ensure that every element of your architecture can justify itself. Don't add things just because that's the way you do things. Don't blindly follow a style or expert. And don't push the same architecture onto everything that you do. And learn from your failures. Check your ego. If you can't look at something you've done and suggest ways of doing it better, then it's really time to find a new profession. And we're done. We might have a couple of minutes for questions. Yes.
You mentioned about writing your own reusable components, and you mentioned copy-paste, which can be a bit of a hell. I presume you're advocating separate repositories for separate projects.
What I'm suggesting is that don't try and write things reusably from the beginning, because you're not going to guess correctly how they're going to be used. If somebody else in your organisation has put in their project that would be useful in yours, grab it, pull it in, you own it now. If it turns out that then they've evolved in kind of the same way and there is actually opportunity to consolidate those and you have the structures in place to actually deal with that third-party project and maintain it and keep it consistent, and it won't diverge for your other projects, which is a whole bunch of conditionals on it, then it might be worth doing so. But a number of organisations have created reusable code libraries in the past, and generally they don't go very far. And I don't want to mention patterns and practices as being terrible people because they're not about me. But let's just pretend I didn't. But yeah.
On the same note, if you were pulling this thing out, what are your thoughts on open sourcing it? Because it sounds like it's probably not competitive enough.
I'm a big fan of doing that. Now, obviously, you need to make sure you have the appropriate authorization, because most people who aren't working for themselves will have a contract in place that says everything you own belongs to your employer, and putting it up on GitHub under an Apache license might be slightly in violation of that. A lot of organizations, though, are getting better at saying, yes, we open source stuff. I've worked for a number of organizations and currently do that have no issue with putting things that aren't specifically the things that add their business value up open sourcing. Now, don't expect that you'll put it up and magically you'll get a community and people will maintain your code for you, because most of the time what you'll hear back is crickets, and you might have one person who looked at your project and thought that was cool and went on and did something else. But basically, in most cases, if you're doing that, there's really no extra cost in open sourcing it, and I would be a fan of it. But you can't just arbitrarily decide to do it on your own unless you're the boss. Anything else, or can we get on to a lot more? Cool.